This is URK 19CS1093, Experiment 2, User-Defined Functions using C++. First question is to develop a C++ program to find Fibonacci series of any number using function. Using find Fibo int and use the above function in order to form a pattern in Fibo underscore pattern int level. So this is the pattern that we should print. Let's see the program. So here hash include IO stream using namespace std. This is the function prototype for find Fibo. This is the parameter passed. It's an integer, and this is the function prototype for Fibo underscore pattern, and this is the parameter integer parameter passed. Inside the main function, we are declaring a variable called n, and we are entering the limit and from the user, and it is stored inside the value n using sin, and then we are calling for Fibo underscore pattern argument n. Then coming out of the main function, this is the function definition for find Fibo. The argument passed int a, and inside this function we are declaring x integer values x equal to 0, y equal to 1, and z. And using a for loop, we are initializing I equal to 0, I less than a, and I plus plus. And inside the for loop, we are printing y first, that is 1, and then z equal to x plus y. We are calculating x plus y and storing its value into z. Then we are storing y's value into x, and then z's value into y. Then coming out of the for loop, and after that function, this is the function definition for Fibo underscore pattern, and this is the parameter pass int n. This is for printing the pattern, and this is a for loop for it. Initializing I equal to 1, I less than or equal to n, I plus plus. Inside this, we'll be calling find Fibo printing n. Sorry, printing I, and new line will be printed n l. So let's see the output. I'm entering 5. This is the Fibonacci series pattern print. Second question. Develop a C++ program to find all Armstrong numbers between the given intervals using functions. Find Armstrong number int, pass two integers which represent starting interval and ending interval as arguments to the function, and display the result in the same function. So here an hint has been given. An Armstrong number is an n-digit number that is equal to the sum of nth powers of its digit. So let's see the program. This is the program for Armstrong. So first we have to declare all this hash include IOStream, hash include math.h, because we are using power function inside this, using namespace std. Now this is the function prototype for find Armstrong, and these are the parameters int s and int l. These are the main function. We are declaring s and l as integer values. We are getting its value from the user, and it's been stored into s and l using sin. And then we are calling find Armstrong arguments s and l value. Then coming out of the main loop using this is the function definition for find Armstrong, and these are the arguments passed int s and int l. Inside the function, there's a for loop where I is equal to s, that is the starting value, and I less than or equal to l, that is the ending value. Then I has been incremented. Inside the for loop, we are declaring some integers like digit, sum1 equal to 0, num dig is equal to 0. And here we'll initialize i's value into, and or i's value will be stored inside the variable called num. Using a while loop, we'll check whether num not equal to 0. If this condition is true, then num has been divided by 10, and then dig is incremented by 1. This is for the number of numbers, counting the numbers, and then i's value is stored to the variable called num. Then using another while loop, we'll check whether num is not equal to 0. If this condition is true, then digit equal to num or less than. This is to get the last digit of the number, and then we'll be adding that into the variable sum 1 plus equal to, and we'll be getting the power of digit comma dig, and then we'll be dividing the number by 10. And coming out of the while loop, then another we are using a if condition. We are checking if someone equal to I. Then if the condition is true, then we'll print I with the tab space. So let's see the output. So starting value I'm typing 100, and ending value I'm typing 600. So these are the Armstrong numbers which are present between intervals 100 and 600. See the third question. Develop a C++ program that allows the user to perform arithmetic operations on two numbers. Your program must be menu driven, allowing the user to select the operation plus, minus, multiplication, or division. Input the numbers. Furthermore, your program must consist of following functions. Functions show choice. This function shows the options to the user and explains how to enter data. Function add. This function accepts two numbers as argument and returns sum. Function subtract. This function accepts two numbers as argument and returns the difference. Function multiply. This function accepts two numbers as argument and returns product. Function divide. This function accepts two numbers as argument and returns coefficient. Let's see the program. Now hash include IOStream using namespace std. This is the function prototype for choice, entering the choice. Then this is the function prototype for addition. The parameters passes int a and int b. This is the function prototype for subtraction. This is the function prototype for division, and this is the function prototype for multiplication. And inside the main function, we are declaring integer variables like a, b, and choice2, and we are declaring a string variable called c, and we are storing s value into that string c. Then using a while loop, we are checking the condition if c equal to yes. If that condition is true, then we are asking the user to enter the first number, and that value is stored into a using sin, and asking to enter the second number, and that value is stored into b. And in the choice function, we are asking the user to enter his choice, and that has been stored into the choice2 variable using sin. And using a switch case, we are checking the case 1 as addition. We are calling the addition function. Case 2, we are calling the subtraction function. Case 3, we are calling the division function. Case 4, we are calling the multiplication function. And if the user enters some wrong choice, it will show the default as not available. And coming out of the switch case, then we'll ask the user whether he wants to continue his program. If it is, and ask whether yes or no, and if and that in out the value entered by the user will be stored into choice2. And using an if condition, we will check whether if choice2 or the choice2 equal to 1, that is yes, then that means yes, and else if it is choice2, then it is no. So else if we are checking another condition, if choice2 is greater than 2, or choice2 is less than 1, if any of the condition is true, then it will print enter valid option, and that will be stored to choice2. And using another if condition, we are checking if choice2 is equal to 1, then it is yes. Else if another condition is choice2 equal to 2, then it will print no. Then coming out of the main function, this is the function definition for choice. This all the choice have been printed. First is addition, second is subtraction, third is division, and fourth is multiplication. Then coming out of that, this is the function definition for addition, where two arguments are passed in a and in b, and in that we'll be printing a plus b with a new line. And this is the function definition for subtraction. Parameters are int a, int b, and we'll print a minus b with a new line. And this is the function definition for division, and they will print a divided by b with a new line. And this is for function definition for multiplication, and they will print a into b with new line. So let's see the output. So under the first number I'm entering 30 here, and second number as 5, and the choice which I'm entering is division, that is 3. So 30 divided by 5, it gives 6. So it's asking the user whether you want to continue or not. So I'm giving yes in one more operation. So I'm entering another number, and I'm entering another choice, that is 1 addition, that will give 20 plus 10 is 30, and they're asking do you want to continue. I'm giving no. Now let's see the next question. Develop a C++ program to find the given numbers are amicable pairs or not using functions. So amicable pairs means if the factors of two numbers, if the sum of the factors of two numbers is equal, then they are called amicable pairs. So hash include IOStream. Let's see the program. Hash include IOStream using namespace std. This is the function prototype for amicable, and this is a parameter, that is int a. And inside the main function, we are declaring two integer variables, that is a and b, and we are asking the user's input, and will be stored into a and b. Then using if condition, we are checking whether the function amicable of a equal to amicable of b. There are two numbers, multiple, it can be used for multiple numbers, and we'll be printing if this condition is true, then they'll print they are amicable pairs, or they'll print not amicable pairs. So this is the coming out of the main function. This is the function definition for amicable, and this is the argument passed int a. So that we'll initialize sum equal to 0. There is a for loop in which I will be initialized as 1, I less than or equal to a, and I plus plus. And inside that, we are checking a condition whether a modulus I equal to 0. That is, if a is divisible by I, then sum will be sum equal to sum plus I, and it will return sum. So let's see the output. So first number I'm entering is 220, and second is 284. So the output is they are amicable pairs. So let's see non-amicable. They are not amicable pairs. So the sum of factors of that two numbers are not equal. That's why they are showing not amicable pairs. So let's see the last program. Last program is to develop a C++ program to find GCD of two numbers using functions. Find HCF and int. Pass two integers as argument to the function and display the result in the same function. So here hash include IOStream using namespace std. This is a function prototype for the GCD number, that is HCF int. And inside the main loop, main function, we are declaring three variables x, y, GCD. X is for the first number, y is for the second number, and GCD is to store the value of the to store GCD. Then we'll get the input from the user and will be stored into x and y. Then we'll be storing the function, we'll be calling the function HCF x comma y, and we'll be storing that value into GCD, and we'll be printing that value of GCD with a new line coming out of the main function. This is a function prototype for HCF, and this is the arguments passed int x and int y. And inside that, we are declaring two variables, temp and remp. Temp is for storing the temporary variable. And using if condition, we are checking whether the x is less than y. If this condition is true, then x is stored inside temp, and y is stored inside x, and temp's value is stored inside y. Coming out of the if loop, then we are checking another while loop. If y not equal to 0, that is the second number. If the second number is not equal to 0, if this condition is true, then rem equal to x modulus y. First number modulus second number, and y's value will be stored into first number, and the rem value will be stored into y. Then we will return the first number x. So let's see the output. So here the numbers entered are 4 and 12. So the GCD of the number will be 4. This great common divisor will be 4. 4 and 12. Thank you.